Okay, so another statistical distribution example. So we've got biased four-sided dice with faces numbered 1, 2, 3, and 4. It's rolled, and the number rolled is modelled as a random variable x. We're given that the probability of x equaling x, as in the random variable equaling a specific number, is equal to k over x. And then we're going to find the value of k. We're going to write out the probability distribution of x in table form, and then use that to find some probabilities at the end as well. Okay, so to find the value of k, it's all to do with probabilities adding up to 1. So first thing to note is that probability that x equals 1 would be as though we were substituting 1 in place of x there. So probability that x equals 1 is k over 1, so just k. The probability that x equals 2 would be k over 2, because we're substituting x equals 2 in there. And similarly, if we want to find the probability that x equals 3, we substitute in 3 for x, so that's plus k over 3, and the final one would be k over 4, because we're substituting 4 in place of the x. So we're going to add all those up, and then from there we're going to be able to solve, because all those 4 probabilities must add up to a whole one. Okay, so adding those up will give us that we've got 25 k over 12 equals 1, and so therefore k is 12 over 25. Okay, so now we've got that, we can start working out some probabilities in the table. So in the table form, we want to have the top row saying just x, so lowercase x, that's standing for the specific values that we can roll on the dice, which are 1, 2, 3, and 4. And then underneath, we want the probability that x equals any of those values. So probability that x equals 1 is just k, so that's 12 25ths. Probability x equals 2 is k divided by 2, so that'd be 6 25ths. And probability x equaling 3 would be 12 25ths divided by 3, which is 4 25ths. And then finally, probability x equals 4 is k over 4, which is 3 25ths. So we've got the table there, and then the table's going to make answering the final question reasonably simple. So the first thing we want is the probability that x is greater than 2. So that's really x taking the values 3 or 4. So we just need to add those respective probabilities together to get 7 25ths. And then the probability that x is between 1 and 4, well, that means that x would be either 2 or 3. So we want to add the probability of getting a 2 and the probability of getting a 3 together. So we're going to get 10 over 25, or if we want to simplify it, we can make that 2/5. And then the final one, probability x is greater than 4. Well, that's impossible because the highest thing is 4, so the answer is therefore 0.